Okay, welcome back to the next part. So here we're going to talk about the section 43C, which is about cumulative frequency. Okay. Cumulative frequency, you should have seen from before. And let's just have a look at how it appears, first of all, in terms of the table that you may use to construct it. So we're going to be talking about some continuous piece of data and frequency for groups. And then you will often use this in a separate table or just a table with another column to talk about cumulative frequency. And look at the way that this is written. So here we were looking at heights between 120 and 130. Here, this is the same. So what's the cumulative frequency? Well, it's just the frequency. Cumulative frequency means that as we go down here, we need to add these values together. We're keeping a running count of the total of the people that we have talked about, which is very, very useful if we want to talk about medians and quartiles and things. Next, we look at how many people are of heights from 130 to 140. But if you look over here, this says people's heights from 120 to 140. So it doesn't just include the people in this group here, it includes the people in the group before. So that's why we're going to add these together. Cumulative frequency, we're going to keep track of a running total. So 40 and 15 is 55, take away the 1, 54. And hopefully it makes sense why then this is written the way that it is. We keep track of this running total and we would expect at the end, okay, to get 100 people. So this is a cumulative frequency table. And just to check some of these questions here, how many students were at most 140 centimeters tall? Well, here I'm looking at everybody from 120 to 140. So the cumulative frequency table is very easy to use to answer questions like this. How many students were more than 140 tall? Well, 54 were less. There's 100 in total, so this must be 100 take away 54, which is 46. Okay, in which class interval is the median height? Well, 54 is the area in which we've gone over the half n threshold. So this is in 120, okay, up to and including the way that it's written, 130. If you see a frequency table like this, before we go any further, you'll be able to see that there's a mistake. So this is accumulating the groups. Frequency is going up, but it's not here. So clearly there's a mistake. Cumulative frequency should always be going up. That's if it's cumulative frequency. And from GCSE, you might remember, we can plot this information. So if this is our table, or it may be written slightly differently, we can plot each of these. And notice how we use these values. So we're going to use the time, and we're going to use cumulative frequency. Frequency is less useful. This is more used for calculating cumulative frequency. If I want to plot it, notice that 9.6 is the first point of interest. There's no frequency there, but this is the first sort of number that I start talking about. And 9.7 I've plotted at 1. So 9.71 is really like a coordinate to plot. So let's check our next one. It should be 9.9 and 5 because we plot the cumulative frequency over here. Keeping it going, 10.05 and 15. And okay, 10.232. And although this is drawn with straight lines here, you should do this with a slight curve to it. Okay, despite the fact that we might be talking about linear interpolation, which assumes there is a straight line here, for the purposes of sketching, we want these points clearly marked, but joined up with more of a slight curve to it. And you might remember from chapter 2, we said Well, we can use these diagrams to estimate medians and quartiles and things. And that's really where linear interpolation came from. So we note that it goes up to 32, which we can see here and here. So the halfway point is 16. The quartile 1 point will be 8, because 8 is a quarter of 32. And you can find 3/4 here. You can use these values to calculate quartiles and things like interquartile range, which is the difference between the lower quartile and the upper quartile, here and here. So you could have just a quick go at this one here. This is 150. So the 1/4 point must be 75, must be sort of 37.5. So something like this. Okay, 42, 43 might be this value here. If we add this on to 75, so what did we say? 37.5 plus 75, we will get our value up around here. We'll be able to mark it down, and you would be able to use this to find your interquartile range, which should be approximately 10. Other questions? You may have questions like less and more and so on. So just take your time to remember that what this graph shows you is it shows you an ordered sort of distribution of running times here. So you have very, very quick people at the bottom, less quick people here, sort of more average people in the middle, and the slower people here. So how many had a time of less than 10.15? Well, 10.15 is here. And 10.15, what you're doing is you're adding up all the people here. So everybody to the left here, these 26 people, these were the fastest people on the left, the fastest 26 people. So these 26 runners were very, very quick indeed. Whereas the 6 people left here were the slowest 6. So I always find it's useful just putting this into context, what this shows you. How many had a running time of more than 9.95? Well, here you're looking at 8 people. 8 people ran in 9.95 or less. Okay. How many were 9.95 or less? It was 8 people. So now we're talking about more. Okay. So it means everybody apart from these 8 people. So 32 take away 8, we should get 24. Estimate how many between 9.8 and 10. So it looks to me like we're going from 3. There were 3 people up until this point here. And then there were 12 there. So I would say it looks like we're talking about, okay, all right, well, slight difference here. They're saying 11. So this is a bit of an, oh, sorry, I picked the wrong point there. So yes, no, it should be, what does it say? 10 seconds. So it should be about here, and they're saying that this is approximately 11. So I would just look at the numbers between these and find the difference. Okay, a couple of questions for you to have a go at there, but then the exercise from the book 3C.